Now we will discuss about nucleotides. There are two types of nucleotides. First one is ribonucleotides and the second one is deoxyribonucleotides. Ribonucleotides, when polymerized, they result in the formation of RNA, and deoxyribonucleotides results in the formation of DNA. Okay. Difference between ribonucleotides and deoxyribonucleotides. There are two differences. First one is the sugar which is included in the ribonucleotides and deoxyribonucleotides, and also nitrogenous base. One nitrogenous base is different in both. Here uracil is absent. Uracil absent, and on the place of uracil here is thymine present. Okay, but here uracil present but thymine is absent. So now we are going to discuss about like a summary table, okay, to summarize all the formations of these ribonucleotides and deoxyribonucleotides, and we will see how to name these nucleotides. Okay, so let's start with the summary table for ribonucleotides, then we will discuss about deoxyribonucleotides. So firstly, as we know that we are having a nitrogenous base, and if we add a pentose sugar on the nitrogenous base, then it results in the formation of a nucleoside. If the nucleoside is added with a phosphate group, then it results in the formation of finally a nucleotide. So this whole process we know very well. Okay, so let's start to draw the table for ribonucleotides. Ribonucleotides, there are 4 ribonucleotides. First one is like on the basis of nitrogenous bases. For the nitrogenous base, first one is adenine. If on the adenine we added a pentose sugar, the pentose sugar will be, yes, the ribose sugar. Ribose sugar. Then it results in the formation of adenosine. Learn the names of these nucleosides. Nucleoside is adenosine. Okay, and now if this adenosine is further added by a phosphate group, or if I say if the phosphorylation takes place of the adenosine and one phosphate group is added, then it forms adenosine monophosphate. Okay, adenosine monophosphate can also be called as adenylic acid. Adenylic acid or adenylate. Adenylate. So now second one is guanine. and we added ribose sugar on guanine, it results in the formation of guanosine. And if guanosine is again phosphorylated and we added a phosphate group on this, it results in the formation of GMP, which is also known as guanylic acid or guanylate. Okay, the third one is cytosine, and if we added a ribose sugar on cytosine, it results in the formation of cytidine. Cytidine, not guanosine, so cytonosine or something else, but it is cytidine. And then phosphorylation of cytidine takes place, and after phosphorylation, the nucleotide which is formed is cytidine monophosphate or cytidyllic acid. And the finally fourth one is uracil, and then the nucleoside is formed is uridine. And if further phosphorylation of uridine takes place, it results in the formation of uridine monophosphate, which is also termed as uridylic acid. Okay, so this was all about ribonucleotides. So without wasting our time, let's move towards deoxyribonucleotides. So now the first nitrogenous base is adenine. Now for deoxyribonucleotides, which pentose sugar are we gonna use is, yes, deoxyribose. Okay, if we added deoxyribose on adenine, then the nucleoside formed is deoxyadenosine. And if the phosphorylation takes place for deoxyadenosine, then the nucleotide formed is deoxyadenosine monophosphate, and this is also known as deoxyadenylic acid. Now for guanine, if we added deoxyribose sugar on guanine, the nucleoside formed is deoxyguanosine. And if phosphorylation of deoxyguanosine takes place, it results in the formation of deoxyguanosine monophosphate, which is also known as deoxyguanylic acid. Now cytosine, if we added deoxyribose sugar on cytosine, it results in the formation of deoxycytidine, and deoxycytidine is, if phosphorylated, then it results in the formation of deoxycytidine monophosphate or deoxycytidyllic acid. And the fourth one comes is thymine. if we added a deoxyribose sugar on thymine, then it results in the formation of deoxythymidine. And if phosphorylation of deoxythymidine takes place, it results in the formation of deoxythymidine monophosphate, which is also known as thymidilic acid, thymidilic acid. Okay, so now we completed ribonucleotides and deoxyribonucleotides. In this summary table, the question which can be asked is just what type of sugar is present. Like the examiner will give you anything from this, like DAMP or anything. Okay, so he will ask you, he will give you some name from all these, or maybe the more phosphorylated form of these nucleotides. That ATP, in ATP what type of sugar is present. Okay, and the examiner will give you four options. One will be ribose sugar, deoxyribose sugar, both, or some other sugar name the examiner will give you. So we know in D, ATP, DMP or anything, the sugar present is deoxyribose. But in ATP, the ribonucleotides, the sugar is present is ribose sugar, not deoxyribose sugar. Okay, so yes, one more thing. The nucleotides which we have formed now for deoxyribonucleotides and for ribonucleotides are in inactivated form. These are of inactivated form of ribonucleotide, deoxyribonucleotides or nucleotides, we can say. These nucleotides, the monophosphate form of nucleotides are inactive. Okay, when there is like replication or something, transcription, etc., where we need nucleotides, then these inactivated nucleotides are activated by further phosphorylation of these. Okay, so like in RNA replication, these inactive nucleotides like AMP, GMP, CMP and UMP are further phosphorylated to form the triphosphate form, which is the active form, and then these nucleotides are further bonded each other to form the RNA or DNA. So now we have completed all about nucleotides and their basic structures, and there are some purine and pyrimidine and nucleotide analogs which are clinically used in treatment of many of the diseases. So the only thing now we are just gonna do firstly are looking after for that nucleotide analogs. Okay, so which are very important in clinical medicine to treat the many of the diseases. So here goes purine, pyrimidine and nucleotide analogs. Okay, so first one is allopurinol, which is used for the treatment of gout or hyperuricemia. Okay, hyperuricemia is a situation in which uric acid is excreted in excess, is formed in excess amount and get excreted through the urine. Okay, and gout is a joint related disease. Okay, and the second one, gout or hyperuricemia. So like gout is also a disease related to hyper excretion or hyperformation of uric acid. Okay, the second one is 5 fluoro uracil. The third one is 6 mercapta purine, and the fourth one is 8 azoguanine. 5 fluorouracil, 6 mercapta purine, and 8 azoguanine. These all three are used in the treatment of cancer, like esophageal cancers, cervical cancer. Example. Okay. The fifth one comes here is azathioprine. The azathioprine, when gets inside our body, it is converted to 6 mercapta purine, and then helps in treating the autoimmune diseases. Like arthritis. The sixth one comes is arabinosyl adenine, which is also like denoted as small a RA, arabinosyl adenine. Okay, this is used in the treatment of neurological diseases. For example, viral encephalitis. And the seventh one is arabinosyl cytosine, which is also represented as ARA capital C. It helps in the treatment of cancers like leukemias. Okay. So, and the last one is zidovudine. Zidovudine. The zidovudine is used for the treatment of HIV or AIDS. So now the first part of our video is completed. I hope you all are like able to understand what I wanted to make you understand. So if you all like this video, so please, if you have not subscribed my channel yet, please subscribe to my channel, and please, I'm looking forward for all of your suggestions, and your suggestions are very precious to me, and thank you so much.